Safe and sound software for digital execution. Safe and sound, my title is about safety and soundness. I'm a CIO at Deutsche Bank. I'm the global head for safety and soundness. So what is safety and soundness? Let's talk about that a little bit before we dive into more of the presentation. Safety and soundness, to me, reminds me of the lightning and thunder a few years back that you guys may know about. Oh, I'm sorry, I'm in Boston? I didn't mean that, sorry for that. But they never won, by the way. They were thunder and lightning. I didn't see much thunder and much lightning. And they didn't win against, I guess they didn't have the glue on their helmet. So they didn't win here. But that's really what it is. It's really the safety and the soundness. We'll talk about that in a minute. It's also maybe another image would be kind of the Batman and Robin of IT. The only issue that I have with this particular image is that usually Batman and Robin come at the end to save the day. Safety and soundness is really about how can we make the digital enterprise more safer, and more sound, but right at the get-go. And we'll talk about what I've been doing at Deutsche Bank, what I've been doing in my career about this particular topic, not just when things happen, but before things happen, so that we tend to avoid them. So let's talk about some of the experience in the space and how can we raise the bar when we talk about digital execution, because it's all about execution. Nowadays, we talk about digital enterprise. We talk about how we become more nimble, faster for the change, more innovative, and that's all great. But at the end of the day, if the CIO doesn't run the system an organization has today, the CIO doesn't have much chance to see tomorrow in that organization, or even the organization might not even see tomorrow. So it's extremely critical for us CIOs to run the systems that exist today in our environment. And that's what I want to talk to you guys about today. So along my career, here are three key critical success factors that I learned about that I wanted to share with you today. One is about hyper-awareness. I've seen so many times IT organizations that are not fully aware of how their end users are using the software. Actually, interestingly enough, I was checking a few surveys before coming here today. Do you know what is the happiest job in America? According to Forbes magazine. And as of 2016, and it's been the case for the past few years as well, it's part of the top 5. And the happiest job in America is supposedly the software QA engineer. Not sure there's much awareness there, because if you were to ask end users, we might not be in that lot. But seriously, around hyper-awareness, it's about what I ask my production support people that are supporting those applications, is really to understand how the application is really used day in, day out. It's around operational intelligence. It's around connecting the dots all the way to the customer with the different parts of the IT, not just the piece of software, not just the infrastructure, but the whole stack, all the way to the customer. Very often, they don't always realize how an application is being used. And actually, in my past, we've sent a number of our developers to the users, to the customers, to see how they were using our software and whether or not they were using it the way it was intended to be used. And lo and behold, we had quite a bit of surprise there, seeing some of our users using Post-its and multiple screens and multiple applications that were really not designed to work together. So that was kind of the first basic thing to do. And I think that sometimes we don't do enough of that. And think about the folks that are deep into IT operations that support the servers and all these systems that don't mean much to the end user, because what the end user sees is really the graphical user interface. That's also really critically important. Think about all the partners nowadays with the platforms that we have to deal with that we need to connect to so that our applications actually can work and deliver the value to the end user. Often the system is down because one of our partners' system is down, and bringing us all down together. So you have to also look at that. And it's pretty much what I refer to as prod ops. Prod from product, production, all the way to operations, kind of beyond DevOps. It's really encompassing the entire stack to focus on the customer experience. So that would be number one. Number two is about operational readiness. It's more than coding and then sending that over to the production folks when it's ready for the release. It's about thinking about it even at the planning time. So it's what I refer to as moving to the left. So if you look at the SDLC lifecycle, from the left, planning, design, construction, testing, and the deployment operations, so towards that left there. It's working with the folks that will be supporting this software, this system, so that they are involved much earlier in the process, so that they can shape how we plan, how we prioritize different features, functionalities, how we take into account all these different parameters that we typically call non-functional requirements. But frankly, it's the first functionality. The system is down. The other functionalities are not going to be of any matter anyhow. So that's extremely important. And then it's about automating this entire value chain, the SDLC value chain, to make sure that at the time when we go to release, the software is ready and is going to work as expected. We'll have all the instrumentation that we expect and so forth. And then the other thing that I want to talk about would be fail fast, learn fast. Even though I have a tendency to be focusing more on production, I am very keen on having people adopt Agile and DevOps. Agile and DevOps are, I think, the two strong pillars for us to create better software, better platforms, as we are actually learning how those platforms and software is behaving, as we're learning how the users are using all of this, it really protects us much better, makes our system safer and more sound. So it's a very important part of my past experience there. In a previous organization, we moved the IT organization from waterfall to Agile, 5% Agile at the time when we started to about 85 when we finished in about 2 years. And this was a big, big difference. Now, to do all of this, obviously, we have to realize that everything is based on the software, and that's one thing that I want to talk about today. Software is eating the world. Without software, we don't have much. Software is in our day-to-day lives. I'm not going to go through the long list of pieces of software that you guys all know about, but it's in our day-to-day life when, for instance, being French, last year I was made aware of one day during weekend where all the French railway was down. And no, it was not a strike at the time. It was one line of code in a piece of software that was wrong, and the entire system was down for a day and a half, and nobody could move around the country at all. So it's just one line of software. So this is really critical. And when you have now software driving cars for us, it's going to be even more important. I think one thing that is different from the past is the software that is growing at a faster pace than ever before. Every 42 months, you double the amount of software, okay? Every 18 months, the Gates law, you slow down the software performance by 50%. And remember that CIOs, and I actually question that particular metric, I'm not sure that we actually make the 51.6 months, most of us. But think about this. That means that in our tenure, the software compounded rate would have decreased from performance perspective by more than 75%. And that's really critical. So what we have today is we need to know our software much better than ever before. Okay? In the past, we didn't have a lot at our disposal to do that. Nowadays, very similar to what the medicine industry has seen, right? We used to have the microscope. Now, if you look at actually the MIT Institute of Brain Research, is around the corner here, has better tools. The same way we have better platforms today for software intelligence. So we need to make good use of it. I'm going to share with you another fact before I get into some examples, is we also have to remember that more than 50% of our developers have less than 5 years experience. How do you feel about your software now? And hold on, there is another fact there. Just before lunch is good. 70% of those software developers are recognizing and realizing that they are self-taught. And by the way, if you're like me, most of my software developers are not working for my company. They're working for a third party that is a provider to us. All right? So how do we feel about that now? So we really need to dig into the software. We need to put all the controls in place so that we can go faster, so that we can go Agile, so that we can go DevOps, and we can sleep at night knowing that the software is as strong as it can be. Examples of that was, in my previous job, we deployed a number of practices and platforms to help us with this. Like I said before, we moved to Agile. These numbers are not made-up numbers. They're really what we saw in terms of productivity, but also in terms of quality gain, which was quite amazing at the time. Actually, there is an article at the IEEE that if you guys are interested in researching, It's from my colleagues at Fannie Mae, where we did that at the time. That explains how we got to this. And one of the things that we used was a platform that allows us to look at software quality. They were not allowed to go to production if their total score, which is kind of represented by the different colorful boxes up there, was not higher than the previous release. So I didn't expect them to have a minimum because they came from software PCs that were really old and not in great shape. But I wanted every release to actually be better than the previous release. And then they also had to have the security score higher than the security score they had in previous release. Otherwise, they would not go to production. We were able to actually measure the total quality index. We were able to actually measure the function points automatically so that nobody would argue about the value of the release. And we were able to manage together the investment required to actually minimize the technology gap and technology debt that we were seeing in our software. So that's one example. We had about 60% of our apps on it, and all the critical apps were on it, and we were using that to focus our investment, making sure that we had the right quality there. Another example is what I'm doing today, actually, at Deutsche Bank, where we're using a risk scoring mechanism where we're taking pretty much all the data that's coming from our different systems, and we create predictive analytics around this data, which allows us to monitor a risk score that is based on the incidents that we see on these particular pieces of software and those systems. And we feed that into that scoring mechanism that allows us to actually identify where we have highest risk and where we have low risk. The important part there, and that's kind of the red line that you see on this particular page, is the direction of travel. There again, like in my previous example, we're not looking at things from an absolute perspective, but more relative, and making sure that we're making progress. So this is another way of looking at software quality and for us to up our game. Overall, and I'm going to close on this, yes, 3 key success factors: hyper-awareness, operational readiness, and then fail, but obviously learn fast are the keys. But remember, at the end of the day, it's all about software. You need to know what's in your software, okay? That's all for today. Thank you very much. Enjoy lunch.